Hi class, welcome back and happy Friday. If you check out the notes behind me on the board here, just a quick overview of where we've been and where we're going. And I'm going to start with that little JPEG, a little picture I sent home along with the daily note. And the JPEG had on it a picture of recent earthquakes in California and Nevada. And that one was sent for a couple of reasons. One, there was a big earthquake yesterday out east of Yosemite, out in a place near a place called, we studied it a little bit, called Mono Lake. It was a 6.5. And if you look at the map, all the little squares on the map, the different color squares, it's put up by the U.S. Geological Survey, the USGS, every single day. And it's very, very cool, but one thing that I think jumps out at you is just how many earthquakes hit in California and Nevada every single day. There's hundreds of them, and the ones that they list on the map are just the larger ones. You can click on one of the squares and it'll pop up and show you exactly how large it was, where it was centered, what time it hit. So it's very, very interesting, but it also, again, ties into our study of evolution. If you check out also the current events tie-in on CNN 10, they do a little bit more with the coronavirus and a little bit more with the map of the spreading of the virus. So it's a very interesting one there, so do check that out. And jumping back into evolution, if you look right here at the 4.3 billion year history of life on Earth, fitting in with earthquakes, one of the things that we study in here is geology. We study a little bit about how the plates move. Part of the reason that we do that, one, of course, is to find out about the rock cycle and how our planet works. The other is how it fits into biology. When you look at, for example, Europe, just a few hundred years ago, there are some people who thought that the Earth was only 4,000 or 5,000 years old, maybe a little bit older than that. We now know it was hundreds of times older than that. 4.6 billion years is roughly the age of the planet. 4.3 billion years is roughly the time that life has had to evolve on Earth. That's pretty stunningly amazing also, because at the time that the very first single-celled organisms arrived on Earth, or evolved on Earth, with the chemical soup, they call it quite a bit, that was available here in the oceans, the life was taking hold in an environment that was still getting pounded by meteorites, pounded by comets coming in. It was an incredibly harsh environment. If you could, go back in time with the time machine and pop into any era on Earth and just say, hey, what would life look like? You wouldn't probably see dinosaurs or trees or anything like that. Over the vast majority of life on Earth, it was single-celled photosynthesizing organisms. And as you go down the notes right here, starting with bacteria, going to the archaebacteria, the ancient bacteria, the eubacteria, going to protists, which we've talked about, one-celled organisms. Going down this way is, we think, the order in which these organisms evolved. We've talked a little bit about protists. We're spending a little bit of time talking about fungus now, or fungi, the fungi kingdom. One of your assignments was to try and come up with one of the things that you ate yesterday or sometime this week that was produced by or was a fungus. A couple of examples up on the board. I just want to share a couple with you. We've been in this shelter in place now for a couple of weeks, and bread, a lot of people have found themselves making bread over the shelter in place time. Sourdough bread, in particular here in the San Francisco Bay Area, is a kind of a staple. It's one of my favorites for sure. And it's made by fermentation, made by a yeast that does very, very well in the climate here in San Francisco. The sourdough bread, a lot of times a visit to San Francisco is incomplete until you get some sourdough bread here baked in the city. And it's made with yeast. Yeast is a type of fungus, of course. Cheese, soy sauce. I was trying to put up some obvious ones here. Mushrooms, obviously a mushroom. You're eating the fruiting body of a fungus itself right there when you have a mushroom. Again, your challenge, ongoing challenge. If you haven't done it yet, make sure you find out something that was created by a fungus. Fungus is an incredibly diverse. We're going to spend some time with it because we're going through each of these kingdoms of life here, the 6 kingdoms that are recognized right now. And if you check out the 6 kingdoms of life, the 6 kingdoms have incredible diversity in terms of protists and fungus. The fungus are an absolutely incredible and necessary part of the 6 kingdoms. They help, like we said, recycle the things that we have in our environment, and they get the organic material back into the soil, back into the food cycle so that other living organisms can use it. Quick example of this right here, the wine industry in California. Wine and beer made in a very similar way. If you look at fermentation, fermentation is a process that extracts energy from sugars by using yeast, by using a fungus. If anyone's ever seen, like, say, the wine section down the street here, there's Trader Joe's. You go in, there's a big wine section there. Let's talk a little bit about how that's made. Just a tiny, tiny bit as an example of how we use fermentation in the process of making food and drink. You've got sugar and yeast, but the cool part, the amazing part about fermentation is it doesn't use oxygen. Well, at least doesn't use free oxygen directly like respiration does. Instead, it takes sugar, and you remember the chemical, test yourself right here. Do you remember the chemical formula, the basic chemical formula? There's a couple of different ones out there, but the one we've taught in this class of sugar. See if you remember, it's carbon, hydrogen, it's C6, H12O6, big long carbon chain with some hydrogen and oxygen stuck to it. Remember also when we talked about energy, you've got potential energy here, but this potential energy is in the form of chemical bonds. The carbons, hydrogens, and oxygens are holding on to each other with the chemical bonds, and then they can be broken apart, and you can get energy from that. Of course, you can get energy from the sugar, but the yeast do it in a really interesting way. In terms of making wine and beer, in California, that's a very, very big industry up here in the North Bay, for example. You see vineyards when you go through Sonoma and Napa counties up there. What you're essentially doing, you're taking sugar, usually in, for example, wine in the form of grapes. You're putting that sugar into a solution in a bottle, for example, and a bottle of wine, you're capping it off. Now, it's a little bit more complicated than that in terms of the way we purify it, but essentially, you're giving the sugar a solution, a water solution, and whatever other flavoring elements you put on in there, and you're capping it off. But before you cap it off, before you put a cap on here and you make this a sealed environment, you throw in some yeast, you throw in some fungus. What do the fungus do? The fungus think it's a party. If you look at the fungus party that's going on right now, the fungus, the yeast that you've thrown in, say, well, thank you very, very much for the sugar, and they're consuming. They actually start breaking down the sugar for food. When they break down the sugar for food, however, one of the byproducts, one of the things they're getting rid of is ethanol or alcohol. And eventually, and also they get rid of carbon dioxide. For example, in things like beer, the carbon dioxide are the bubbles that builds up in the solution. Eventually, the ethanol or the alcohol content gets so high in this sealed environment. Remember, it's sealed, nothing can go in or out. Eventually, it gets so high in the sealed environment that the alcohol, the ethanol, actually kills the yeast that started the whole reaction in the first place. When that happens, the fermentation is done, and what's left over is a drink that has a whole industry right here in California. So if you look at the food, quick reminder about your assignment, and also if you check out online, the life cycle of a typical fungus is down there, so make sure you put that into your notes. Again, I always encourage you to just draw it in simply in your own way, the life cycle of a typical mushroom. But your assignment, do a little search, check out some of the food that you might have had this week or today that was created by or directly is a fungus. Hope you have a great weekend, and I hope to see you soon. Take care. Bye-bye.